All right, we got ourselves a little video submission for the lab about semiconductors, in this case transistors. We use a variable resistor here in the form of a potentiometer that supplies positive voltage to this NPN transistor. So it supplies it to the base there. The collector side here is powered with 5 volts. And the emitter here side goes to the relay. And when voltage is allowed to pass through this transistor, it energizes the coil of the relay here, which creates a magnetic field that opens or that closes, normally open, and then when it's not under inductance, it reverts back to the normally open side. Each gate in this relay powers one of 2 LEDs, and so yeah, that's basically what we got here. So the transistor has a voltage threshold that the base must be under. It must be under, it must match or exceed a certain voltage threshold, at which point it acts like a gate that allows this voltage to flow through to the relay coil. And what the relay does is it varies the resistance, and the higher the resistance at this point, the more voltage passes through this, and less goes to the base here of the transistor. So when the resistance is higher, there's more voltage being pulled through this resistor than is able to cause this transistor to allow the flow of electrons across the the semiconducting gradient or whatever. But when that resistance is lowered, more voltage is being drawn through here. It exceeds that threshold, and then charge is allowed to pass through, energizing the coil, swapping the gates out. So that's really about it. There's resistors here to prevent LEDs from burning out and stuff like that, but that's not super interesting. But yeah, that's basically what we're going for, and that's basically what we got. So there you go. Alrighty.